Hello everyone. What I'd like to do in this video is show you a shortcut for doing long division, something that's called synthetic division. Now this only works in special cases, but you'll see here once we get to section 3.4 and 3.5, we'll be using synthetic division all of the time. Okay, so what I would like to say is synthetic division, what is it? It's a quick method for dividing polynomials when the divisor is of the form x minus c. So it only works if I'm dividing something by the form x minus c. So now c could be positive or negative. So it could be if I'm dividing something by like x plus 2, x minus 5, x plus 10, x minus 150, something of that form. You are going to absolutely love this method. It saves so much paper. We're going to be saving so many trees. It's going to be beautiful. Okay, check it out. Okay, here's our first example. So before I go on to show you really why it works, I think it's going to be better for me to show you just how it works first, and then I'll do a side-by-side comparison in the next video of polynomial division and synthetic division right beside one another, and you'll see how it's all working together. Okay, so let's say we want to take 3x cubed plus 9x squared minus 5x minus 1, and we're going to divide this by x plus 4. So if we're doing synthetic division, what we're going to do is we're going to do kind of like the traditional long division bar, but it's very common to actually do it upside down. So we're going to write it like this. And what we're going to do is we're only going to record the most essential pieces of this polynomial, of the dividend here, just the coefficients. So we're going to go ahead and write a 3, a 9, a negative 5, and a negative 1. And then what we're going to do is whatever number is right here, I'm going to record the opposite. I'm going to put its opposite here. I'm like questioning how you spell opposite. I'm a math. I majored in math. You're like second guessing when I'm being videoed and I'm feeling like the pressure of having to spell. Is that spelled right? I don't know. Okay, so I'm going to put the negative. Instead of putting 4 here, I'm actually going to put a negative 4 here. Okay, and then I'm going to put this kind of bar here underneath. Okay. So the very first step, the very first thing we're going to do here is the first number here, I'm always just going to drop that down. We're always going to be the first step. And then what we're going to do is we're going to take the negative 4 and we're going to multiply it by 3, and we're going to put our result right here. So negative 4 times 3, we're going to get out a negative 12, and we're going to now add these together. So 9 minus 12, what are we going to get? We're going to get negative 3. So I'm going to put a negative 3 right here. Okay. Then what we do is then we're going to take the negative 4 and we're going to multiply it by the negative 3, and we're going to put the result right here. So negative 4 times negative 3, we get out a positive 12. And then we're going to add these together. So 12 plus negative 5, I think we get positive 7. And then we're going to now take, different color, we're now going to take the negative 4, and they're now going to multiply it by the 7. And we're going to put the result right here. So negative 4 times 7, we get negative 28. So I'm going to write a negative 28, and I'm going to add these together. So we'll end up getting out a negative 29. And I'm going to put a little dash right here for a certain reason. So we're actually done. We've done the entire polynomial division. Look at the space we've saved. But how do I read this? How do I read what I've done here? So what we have here, these first 3 numbers right here, these are the coefficients for my quotient. And what I have right here, this is the remainder. So this last spot, you always kind of put this little line here for the last spot. This is going to be your remainder. And what's right here are the coefficients of the quotient. Okay? So how we read this is the constant spot. This is going to be a 7. This is the coefficient in front of the x. This is the coefficient on the x squared. So the result is the quotient is going to be 3x squared minus a 3x plus a 7. And now I have a remainder of negative 29. So we'll add our remainder and we'll divide by our divisor. X plus 4, and bam, we're done. Beautiful. So that's the answer. Let's do another example. Okay. So let's say we want to divide, let's say 2x cubed minus 5x minus 7, and let's divide that by x minus 2. Okay, so we're going to kind of do this upside down fraction bar. I'm going to record the coefficients, so I have a 2. Now notice that I don't have any x squared terms, so I need to think that it's a 0x squared. So I actually need to put a 0 here, then a negative 5, then a negative 7. This is the most common mistake I see with synthetic division, is forgetting to put zeros in for my dividend. So now what I'm going to do is I'm going to look at this number right here. It's a negative 2. So what I'm going to do is I'm going to flip the sign. So instead of putting a negative 2 here, I'm going to put a positive 2 here. So the first step is I'm going to drop down this first number. So I'm going to drop down the 2. I'm going to take the 2. I'm going to multiply it by this 2, and I'm going to put the result here. So 2 times 2 is 4. I'm going to add these together, and I'm going to get out a 4. I'm going to take the 2, I'm going to multiply it by the 4, I'm going to put the result right here. 2 times 4 is 8, I'm going to record an 8 right here. 8 plus negative 5, what do we get here? What is that? Positive 3. And now I'm going to take the 2, I'm going to multiply it by the 3, I'm going to put the result here. 2 times 3, I get out 6, I'll put the 6 here. I'll add these together, and I'm going to get out a negative 1. And voila, like that, we're finished. Isn't this beautiful? This is so much easier. We're saving so much space. We're saving so many trees. I love it. Okay, so what is the result? The result is going to be a 2x squared plus a 4x plus a 3. Our remainder is negative 1 plus a negative 1 all over our divisor, x minus 2, and we're done. Just like that. I'm going to put 2 of these up on the board, and what we're going to do, because we're going to be doing this so much, we're going to try to do these really quickly. I'm going to put 2 up on the board. I'm going to want you to pause the video and try them on your own. Okay, we want to get super quick at these. We're going to be doing this a lot. Okay, so let's say we have a 2x cubed plus 5x squared plus 9 all over x plus 3. Give this one a shot. And also, how about a 2x cubed minus a 5x squared plus a 3x plus 7 all over. How about an x minus 2? Okay. Pause the video, give these a shot. Okay, for this first one, we'll set up our synthetic division bar. We'll write a 2, we'll write a 5. Notice that there's no x term, so I'll put a 0 and then a 9. I won't put a 3 here. I'm going to put a negative 3 here. I'm going to drop down the 2. I'm going to do negative 3 times 2. I get out a negative 6. Negative 6 plus 5 is negative 1. Negative 3 times negative 1 is 3. 3 plus 0 is 3. Negative 3 times 3 is negative 9. Negative 9 plus 9 is 0. This is exciting. We're always going to be very excited when we have a 0 as a remainder. This is great news. Let me show you. Because what this says is when I do the division, what I ended up getting out is, let's actually write this all down. We get a 2x cubed plus a 5x squared plus 9 all over x plus 3 is going to be equal to a 2x squared minus x plus 3 plus our remainder is 0, so that would be 0 divided by x plus 3. 0 divided by x plus 3. This is just 0. So what I have here, if I just kind of erase this piece, I have this polynomial divided by this polynomial is just 2x squared minus x plus 3, which means x plus 3 goes in here an even number of times. So what's great about this is notice if I were to multiply both sides by x plus 3, what I'll have here is I'll have that 2x cubed plus 5x squared plus 9 is equivalent to 2x squared minus x plus 3 times x plus 3. This is great. Notice I've broken down this polynomial into the product of two smaller polynomials. I've essentially been able to factor this. This is beautiful. This is exciting. Okay, let's do the next one. If you're not excited now, man, when we get to the next section, you're going to get really excited when things like this happen. You'll see. Okay, let's try this next one. Okay, we'll set up our synthetic division bar. We'll write a 2. We'll write a negative 5. We'll write a 3. We will write a 7. Then I'm going to put not a negative 2 here, but a positive 2 here. Okay, we'll drop down the 2. 2 times 2 is 4. 4 plus negative 5, we get a negative 1. 2 times negative 1 is going to be a negative 2. 3 plus negative 2, I'm going to get out a 1. 2 times 1 is 2. 7 plus 2 is 9. And we're finished. Look how quick that was. Okay, so what we have here is this polynomial is equivalent to our quotient, 2x squared minus x plus 1. Our remainder is 9. All over our divisor, x minus 2. And there's the answer. There's synthetic division. Beautiful. Hope you enjoyed that. We'll see you in the next video.